12:45 time man.
Hello everyone. I'm excited to be here as an MLSA beta member. For those who might not be familiar, MLSA stands for Microsoft Learn Student Ambassadors, a community dedicated to empowering students to develop their technical skills and foster a passion for technology. Today, I'm thrilled to lead a session on an event that's close to my heart, Hands-on Git. Hands-on Git is an engaging and interactive event centered around GitHub, the powerful platform that's become a cornerstone of modern software development. Whether you're an aspiring developer or someone looking to sharpen your existing skills, this session is designed to dive deep into the essentials of version control and collaboration. Throughout our time together, we'll explore key GitHub features, including version control basics, branching strategies, and collaboration workflows. We'll also discuss best practices for using GitHub effectively in both individual and team settings. My goal is to equip you with practical knowledge that you can apply to your own projects and enhance your development workflow. I'm excited to be here as an MLSA beta member. For those who might not be familiar, MLSA stands for Learn Student Ambassadors, a community dedicated to empowering students to develop their technical skills and foster a passion for technology. Today, I'm thrilled to lead a session on an event that's close to my heart, Hands-on Git. Hands-on Git is an engaging and interactive event centered around GitHub, the powerful platform that's become a cornerstone of modern software development. Whether you're an aspiring developer or someone looking to sharpen your existing skills, this session is designed to dive deep into the essentials of version control and collaboration. Whether you're an whether you're an Whether you're an aspiring developer or someone looking to sharpen your existing skills, this session is designed to dive deep into the essentials of version control and collaboration. Throughout our time together, we'll explore key GitHub features, including version control basics, branching strategies, and collaboration workflows. We'll also discuss best practices for using GitHub effectively in both individual and team settings. My goal is to equip you with practical knowledge that you can apply to your own projects and enhance your development workflow. Hands-on Git isn't just about learning the technical aspects, it's also about understanding how to leverage GitHub's tools to streamline collaboration, manage projects efficiently, and contribute to the open source community. Whether you're just starting out or have some experience with GitHub, I hope this session will offer valuable insights and inspire you to explore new possibilities. Thank you for joining me today. Let's dive into the world of GitHub and hands-on Git together, and discover how we can make the most of these powerful tools. Certainly. Git is a widely used version control system that provides powerful tools for managing and tracking changes in source code during software development. Here's a detailed exploration of how Git works for version control and its key features. What is version control? Version control is a system that records changes to files over time, allowing you to revert to specific versions, track progress, and collaborate with others. It helps in managing multiple versions of files and coordinating work between different people working on the same project. Git for version control. Git is a distributed version control system that was created by Linus Torvalds in 2005. It is designed to handle everything from small to very large projects with speed and efficiency. Git's distributed nature, along with its robust features, makes it ideal for modern software development. Key features of Git. 1. Distributed version control.
Local repositories. Each developer has a complete copy of repository, including its history and branches. This means that you can work offline and still have full access to the project's history and capabilities. Redundancy. Since everyone clones a full backup of repository, there is no single point of failure. Even if the central repository is lost or corrupted, the project can be recovered from the local copy. Second, branching and merging. Branching. Git allows you to create branches to work on different features or fixes in isolation. Branches are lightweight and inexpensive to create. They enable parallel development and experimentation without affecting the main code base. Merging. Once changes in a branch are ready, you can merge them back into the main branch. Git handles merging automatically but also provides tools to resolve conflicts if changes in different branches overlap. Third, commit history. Commits. Each commit represents a snapshot of your project at a particular point in time. Commits are linked in a chain, forming a history of changes. Commit messages. Each commit includes a message describing the changes made. These messages provide context and help in understanding the evolution of the project. Efficient storage. In that, data storage. Git and delta encoding to store data efficiently. Instead of storing multiple copies of the same file, Git stores the difference between versions, saving space. Object database. Git stores data in an object database. This includes blobs, trees, and commits. The object database ensures fast and efficient access to data. Collaboration and integration. Pull requests. GitHub and other platforms use pull requests to facilitate code reviews and discussions. Developers can propose changes which can be reviewed, discussed, and merged into main project. Remote repositories. Git supports remote repositories, allowing you to synchronize changes with a central server or other developers. Common commands include git push and git pull. Conflict resolution. In that, atomic merging, Git can automatically merge change from different branches when they don't overlap. Conflict detection. If changes in different branches conflicts, Git will mark the conflicts in the file and require manual resolution. Tools are available to help resolve these conflicts. 7. Tagging and releases. Tags. Git allows you to create tags to mark specific points in the history, such as releases or milestones. Tags provides a way to refer to important versions of the project. Releases. Tags can be used to recreate official releases of the project. This is useful for versioning and distributing softwares. Basic Git workflow. In that, first one, cloning a repository. You start by cloning a repository, which creates a local copy of the repository on your machine. Bash git clone repository URL. Making changes, edit files, modify or add files in your working directory, state changes. Use git add to change for committing. For example, bash git add file name. Committing changes. Commit. Commit the stage changes with the respective message. For example, bash git comment m your comment message. Pushing changes. Push. Upload your commits to a remote repository. For example, bash git push origin branch name. Pulling changes. Pull. Fetch and merge changes from a remote repository. For example, bash git pull origin branch name. Creating and switching branches. Create a branch. For example, grid branch name. Switch to a branch. For example, bash git checkout branch name. Create and switch. Bash git checkout branch name. Summary: Git provides a comprehensive set of tools for version control, including branching, merging, conflict resolution, and efficient data storage. Its distributed nature and robust features supports effective collaboration and management of software projects. Understanding Git's capabilities and workflow is crucial for modern software developments, enabling teams to work together seamlessly and manage complex code databases efficiently. Centralized version control system are the type of version control systems where a single central repository stores all versions of the files for a project. This central repository serves as the authoritative source for the project's history and allows multiple users to collaborate by checking out and committing changes to this central location. Key features of centralized VCS. First one, single central repository, centralized storage. All projects, files, and their version histories are stored in one central repository. This repository is the single source of truth for the project. Access control. The central access repository can be secured and access controlled to ensure that only authorized users can make changes. Second, checkout and commit. Checkout. Users check out a copy of their project from the central repository to work on locally. This provides them with current state of project. Commit. Changes are made to the local copy and then committed back to the central repository. This updates the central repository with the latest changes. Third one, version history. Tracking changes. The central repository maintains a complete history of changes, allowing users to view previous versions of files and understands the evolution of the project. Revision control. Each changes or set of changes is tracked with a unique revision number, making it easy to refer to specific versions of the project. Fourth one, collaboration. In that, simultaneous work. Multiple users can work on the project at the same time. They must commit their changes to central repository to share their work with others. Synchronization. Users need to regularly update their local copies with latest changes from the central repository to stay synchronized with the team. Conflict resolution. Handling conflicts. If two users make conflicting changes to the same file, conflicts may arise when committing. The VCS typically provides tools for resolving these conflicts, though the process may be more manual compared to distributed systems. Common centralized VCS examples. First one, SVN, Subversion, a widely used centralized VCS that supports versioning of files and directories. SVN allows for branching and merging but operates with a single central repository. Perforce, Helix cores. Another centralized VCS known is its scalability and performance, particularly suited for large codebases and binary assets. CVS, concurrent version systems, one of the earliest version control systems, though less commonly used today. It also operates with a single central repository. Advantages of centralized VCS. First one, simplicity. Easier to set up and understand, especially for smaller terms or projects. There is a single repository to manage, ma- making configuration straightforward. Centralized control. Easier to enforce access control and backup policies with a single central repository. Third one, consistency. The central repository ensures that everyone is working with the same version of the files. Changes are immediately available to all the users. And moreover, the disadvantages of the centralized VCS. First one, single point of failure. Second one, network dependency. And third one, limited offline works. Fourth one, scalability issues. The single point of failure, the central repository is a single point of failure. If the server goes down or is compromised, the entire project can be affected. Network dependency. Users must be connected to the central repository to commit or update changes. This can be problematic if the network is down or if users are working remotely. Limited offline work. Users cannot work effectively offline. They need to connect the central repository to get updates and commit changes. Scalability issues. Centralized VCS can struggle with performance and scalability issues when handling very large projects or large number of users. Comparison with distributed VCS. Centralized VCS differs from distributed version control systems like Git and Mercurial in several ways. Central repository. In CVCS, there is a single central repository, while in a DVCS, each user have a complete copy of repository, including its history. Offline work. DVCS allows users the single point of failure natures and reliance on continuous network access challenges compared to more modern distributed version control systems. Distributed version control systems represent a significant advancement over centralized version systems by providing a more robust and flexible approach to version control. Git, as a leading example of DVCS, offers a range of features that enhance collaboration, version management, and project history tracking. What is a distributed version control system? A distributed version control system maintains multiple repositories with full project history. Unlike a centralized VCS, where there is a single central repository, each user in a DVCS has their own complete copy of the repository, including its full history and branches. This decentralized model offers several advantages for development and collaboration. Key features of Git as a distributed VCS. First one, full local repositories. Complete history. Each clone of a Git repository contains the entire project history. This means that every user has a full backup of the repository, including all versions of the files and branches. Offline capability. Users can perform almost all operations such as viewing history, creating branches, and making commits in offline. Changes can be synchronized with other when they are reconnected. Branching and merging. Lightweight branching. Git makes it easy to recreate and manage branches. Branches are lightweight and that can be created quickly without affecting the main line of the development. Flexible merging. Git provides powerful merging capabilities to integrate changes from different branches. It uses three-way merge algorithm to combine changes and resolve conflicts. Third one, commit history and tracking. Snapshots. Git tracks changes by creating snapshots of the project at each commit. Each commit has a unique identifier and contains metadata about the changes, the author, and the commit messages. History transversal. Users can traverse the project history, view changes between commits, and compare different versions of files. Collaboration and synchronization. Remote repositories. Git supports remote repositories hosted on platforms like GitHub, GitLab, or Bitbucket. Users can push their changes to remote repositories and pull updates for them. Pull requests. Platforms like GitHub use pull requests to facilitate code reviews and discussions. A pull request allows users to propose changes which can be reviewed and merged into the main project. Fifth one, conflict resolution. Conflict detection. Git automatically detects conflicts when merging changes from different branches. Users are promoted to resolve conflicts manually if there are overlapping changes. Conflict resolution tools. Git provides various tools and commands to help resolve conflicts, including visual merge tools and conflicts markers in the affected files. Tagging and releases. Tags. Git allows users to create tags to mark specific commits as important milestones or releases. Tags provides a way to reference significant points in the project's history. Releases. Tags are often used to create official releases of software which can be versioned and distributed. Efficient data handling. Data storage. Git uses a combination of snapshots and delta encoding to efficiently store changes. Instead of saving full copies of files, Git stores changes between versions. Object database. Git stores data in an object database that includes blobs, trees, and commits. This database allows fast access to the project data. Basic Git workflow. First one, clone a repository. Command, clone a remote repository to create a local copy. For example, bash git clone repository URL. Make changes. For example, edit files, modify files as needed in your local repository. Stage and commit changes. Stage. Add changes to the staging area. For example, bash git add file name. Commit. Save changes with a commit message. For example, commit message. Push changes. Push upload commits to a remote repository. For example, bash git push origin branch name. Fifth one, pull updates. Pull, fetch and merge changes from a remote repository. For example, bash git pull origin branch name. Sixth one, create and manage branches. Create branch, bash git branch name. Switch branch. For example, bash git checkout branch name. Create and switch. For example, bash git checkout b branch name. Seventh one, tagging. Create a tag. For example, bash git tag name. Push tags. For example, bash git push origin tag name. Advantages of Git as a DVCS. Resilience. The distributed nature means there is no single point of failure. If one repository is lost or corrupted, the project can be recovered from any other clone. Second one, enhanced collaboration. Multiple users can work on the different branches and synchronize their changes, facilitating collaborative development. Third one, offline work. Users can work offline with a full copy of the repository, enabling them to perform most tasks without needing a constant network connection. Advanced branching and merging. Git's branching and merging capabilities are flexible and powerful, allowing for complex workflows and experimentation. Summary: Git, as a distributed version control system, offers significant advantages over centralized systems by providing full local repositories, advanced branching and merging, efficient data handling, and robust collaboration. Its distributed nature enhances resilience and flexibility, making it a preferred choice of modern software development and collaborative projects. Understanding Git's capabilities and workflow is crucial for effective version control and team collaboration. Git snapshots. Git snapshots are fundamental concept that underpins its version control capabilities. Understanding snapshots is crucial for grasping how Git tracks changes and maintains a history of your project. What are snapshots in Git? In Git, a snapshot is essentially a record of the state of your entire project at a specific point in a time. When you commit changes, Git creates a snapshot of the project files and directories, capturing their contents as the exit at that moment. Unlike sometimes other version control systems that can store only the differences between file versions, Git takes a snapshot of the entire project and stores it efficiently. How Git snapshots work? First one, initial commit. When you create your first commit, Git takes a snapshot of the file in your working directory. This snapshot is saved as an object in Git's object database. Git creates a commit object that points to this snapshot along with metadata such as the commit message or the timestamp. Second one, subsequent commits. For each new commit, Git takes another snapshot of the project files. If files have not changed since the last commit, Git does not store a new copy of those files. Instead of it reference the previous snapshot, this approach converts storage and improves efficiently. Git only stores the new or changed files as a part of the snapshot, with unchanged files being referenced from earlier snapshots. Snapshot storage. Blobs. Each file contents are stored in a Git object called a blob. Blob is nothing but binary large object. Blobs are identified by a unique SHA-1 hash. Trees. Directories are represented by Git objects called trees. A tree object contains references to blobs, and other trees represent the system of the project. Commits. A commit object that a point tree object that represents the state of projects at that commit. The commit object also includes metadata and a reference to its parent commits. Fourth one, efficiency. Content addressable storage. Git uses a content addressable storage system where each object is identified by its SHA-1 hash. This ensures that identical content is stored only once, regardless of how many times it appears in different snapshots. Delta encoding. While Git primarily uses snapshots, it also employs delta encoding in certain contents to further optimize storage by storage difference between objects. Benefits of Git snapshots. First one, complete history. Each commit represents a complete snapshot of your project, allowing you to view or revert to any previous state. This complete history provides a clear and detailed record of how the project has evolved over time. Second, efficient storage. Git's method of referencing unchanged files rather than storing duplicate copies conserves storage space. By storing only these difference between snapshots and referencing unchanged content, Git maintains efficiently even with large projects. Fast operation. Since Git stores complete snapshots and uses efficient data structures, operations like checking out a specific commit or viewing the project's history are generally fast and responsive. Fourth one, branching and merging. Snapshots enable powerful branching and merging capabilities. Each branch can be seen as a series of snapshots, and merging branches involves combining snapshots from different branches. Git efficient snapshots management supports complex branching workflows. Example of Git snapshot in practice. First one, creating a snapshot. Make changes to files in your working directory. Stage the changes using git add. For example, bash git add file name. Commit the changes to recreate a snapshot. For example, bash git commit your commit message. Git creates a new snapshot and record it as a commit in the repository. Second one, viewing snapshots. Use git log to view the commit history and see the snapshots of your project. For example, bash git log. Use git checkout commit hash to switch a specific snapshot. For example, bash git checkout commit hash. Third one, reverting to a snapshot. If you need to revert to a previous snapshot, you can use commands like git checkout, git reset, or git revert, depending on your needs and whether you want to keep or discard subsequent changes. Summary. Git snapshots are core concept that enables efficient version and project management by capturing the entire state of a project at a specific point in time. Git provides a complete and detailed history of changes. This snapshot-based approach supports efficient storage fast operations, and powerful branching and merging capabilities, making Git a robust tool for modern software development and collaborative projects. In Git, understanding the different areas of the local repository is crucial for effective version control. Each area serves a specific purpose in managing changes and commits. There is a detailed overview of the local Git areas working directory definition. The working directory is a directory on your local file systems where you work on your project. It contains the files and directories that are currently being edited. Purpose: edit files. This is where you make changes to your files, add new files, or delete existing ones. Track changes. Git tracks the difference between the files in the working directory and the files in the staging area. Common commands. Git status shows the current status of the file in the working directory compared to the staging area. Git difference displays the changes between the working directory and the staging area. Staging area definition. The staging area, also known as an index, is an intermediate space where changes are prepared before committing. It acts as a buffer between the work directory and the repository. Purpose: stage changes. You add changes staging area using the git add command. This prepares the changes to be included in the next commit. Selective commits. You can stage specific changes of files, allowing you to recreate commits with only the change you want. Commit commands. Git add file. Stage changes in specified file. Git add stages all changes in current directory and its subdirectories. Git status shows the status of files in the working directory and the staging area. Git diff catch shows the difference between the staging area and the last commit. Third one, local repository definition. The local repository, also known as the Git directory, is a hidden directory located in the root of your working directory. It contains the entire history of your project, including all commits, branches, tags, and configuration settings. Purpose: storage history. It stores all commit branches, tags, and other metadata about the project. Manage version control. It manages the project version history and metadata components, objects. contains objects such as commits, trees, and blobs. These objects represent the state of the project at various points in time. Ref. References to commits, such as branches and tags. These are the pointers to specific commits in the repository. Configuration. Git configuration files that define repository-specific settings. Common commands. Git log shows the commit history in the local repository. Git branch lists all branches in the local repository. Git tag lists all tags in the local repository. Git reflog shows a log of all reference updates, including commits, branches, changes, and more. Summary of Git area and their roles. First one, working directory, where you make a modify files. It reflects the current state of your project as you work on it. Staging area, a preparation area where you stage changes before committing them. It allows you to selectively choose what changes to include in the next commit. Local repository, the database where Git stores the entire history of a project. It includes all commits, branches, tags, and configuration settings. Example workflow using local Git areas. First one, make changes. Edit files in the working directory. Stage changes. Add changes to the staging area. For example, bash git add file. Third one, commit changes. Commit the staged change to the local repository. For example, bash git commit message. Fourth one, review history. View commit history in the local repository. For example, bash git log. Check status. Check the status of the working directory and staging area. Bash git status. By understanding these local Git areas, you can effectively manage and track project history and collaborate with others in a more organized manner. Understanding the basic Git workflow is essential for managing source code effectively. Git workflows facilitate collaboration and version control, allowing developers to track changes, manage branches, and handle updates efficiently. Here's an overview of the fundamental Git workflow steps. Basic Git workflow steps. Clone a repository. Purpose. Create a role, local copy of a remote repository. This step is initial if you are starting work on an existing project that is hosted on a remote server. For example, command bash git clone repository URL. Second one, make changes. Purpose. Edit files in your working directory. This is where you modify, add, or delete files as a part of your development work. For example, edit a file with a text editor or IDE. Check status. Purpose. View the status of your working directory and staging area. This command shows which files have been modified, which are staged for the next commit, and which are untracked. Command bash git status. Stage changes. Purpose. Add changes to the staging area. This prepares the changing to be included in the next commit. For example, command bash git add file. Note: git add stages all changes in the current directory and its subdirectories. Fifth one, commit changes. Purpose: save staged changes to the local repository. Each commit creates a snapshot of the project at the point in the time and includes a commit message describing the changes. For example, command bash git comment your commit message. Sixth one, review history. Purpose: view the commit, command base, and commit messages. Seventh one, push changes. Purpose: upload local commits to a remote repository. This updates the remote repository with your changes so that can access them. For example, bash git push origin branch name. Pull updates. Purpose: fetch and merge changes from a remote repository in your local branch. This ensures it's updated with changes made by others. For example, command bash git pull origin branch name. Ninth one, create a branch. Create a new branch to work on a different features or fix. Branching allows you to work on different tasks independently. For example, command bash git branch name. 10th one, switch branches. Purpose: change your working directory to a different branch. This allows you to work on different branches without affecting your main branch. Command shortcut. You can also create and switch to a new branch in one step. For example, bash git check branch name. 11th one, merge branches. Purpose: integrate changes from one branch into another. This is commonly done to merge future branches into main branch. Command, for example, bash git merge branch name. Resolve conflicts. Purpose: handle conflicts that arise during merging when changes in different branches overlap. Command, after a merge conflict, Git will mark the conflicted files. You need to manually resolve conflicts and then stage the resolved files. For example, bash git add resolve file. Command, resolving conflicts finalize the merge with bash git commit. Summary of the basic Git workflow: clone, git clone, repository URL. Second one, make changes, edit files in the working directory. Third one, check status, git status. For stage changes, git add file. Fifth one, commit changes, git commit message. Review history, git log. Seventh one, push changes, git push origin branch name. Eighth one, pull updates, git pull origin, branch name. Create a branch. Git branch, branch name. Switch branches. Git checkout, branch name. 11th one. Match branches. Git match, branch name. 12th one. Resolve conflicts. Manually edit files, then git add resolve file and git commit. This basic workflow allows you to efficiently manage your source code and collaborate with others, making a Git a powerful tool for version control. Throughout the time together, we'll explore key GitHub features, including version control, basic branching strategies, and collaboration workflows. We'll also discuss best practices for using GitHub effectively in both individual and team settings. My goal is to equip you with a practical knowledge that you can apply to your own projects and enhance your development workflow. Hands-on Git isn't just about learning the technical aspects, it's also about understanding how to leverage GitHub's tools and to streamline collaboration, manage products effectively, and contribute to the open source community. Whether you're just starting out or have some experience with GitHub, I hope this session will offer a valuable insights and inspire you to explore new possibilities. Thank you for joining me today. Let's dive into the world of GitHub and hands-on Git together and discover how we can make the most of these powerful tools. Thank you. Have a great day.